Now let's talk about the construction of a three-phase induction motor first. Okay, so step by step we learn each and every aspect and each and every part and each and everything about the three-phase induction motor. Okay, now here see in front of your screen you can see the three-phase induction motor. Yes, I took the picture. This is what your three-phase induction motor it is look like. Okay, now here from outside, of course you can't make it what type of motor is this, but I am telling you this is motor and which is three-phase induction motor. Okay, now which is actually look like this. Okay, now here there are different parts of a three-phase induction motor, so we are just making it a assembly. Okay, now these are the parts, different parts. Now here you can see this is a cooling fan which is connected over the shaft. This is what the shaft at the center where everything is mounted, this is what the shaft. Over the shaft you can see these are ball bearings. Okay, now see these are ball bearings, steel ball bearings. Okay, ball bearings. Then this is what your squirrel cage rotor, everyone knows it, hope everyone knows it, squirrel cage rotor. Okay, then here this is your stator, now outside the stator, outside part of the stator which is made up of cast iron. Okay, and inside this is slots are there, you can see. Okay, those inside part which is made up of silicon steel stamping, which is laminated steel, and over this we do the winding. Now this you can see, this is what the winding over the stator, this winding we done over the stator. Now this what is winding, we use enameled copper. Now this winding which is three-phase winding, it means three windings are there. Okay, three conductors are there. Okay, now when we are using three conductors, it means 6 terminal of each conductor, one conductor having two ends. So for like that, for the three windings which having total 6 terminal, so here this is a terminal box, 6 terminal outlet, or you can say terminal box, you can say supply box. Okay, so this is your terminal box or supply box, you can say, or wire box also they can say. Okay, so there we can give the supply or give the connection. Okay, so this is your terminal box, supply box, you can say. Okay, then here there is a cooling fan. Okay, this is what your motor look like. Okay, the different parts. Here I have something more which is actually labeled each and every part of a three-phase induction motor. From here see fan cover, here cooling fan. Okay, when motor started, motor getting heat up, that's why they always put a one fan over the shaft, so that the fan gives the air, force air inside the motor, and which is helps that motor to getting cool. Okay, then here there is a end bell, they said, you can say simple a cover, there is a cover, side cover you can say. Okay, wiring box, see we just discussing about this thing. Then there is a name plate over here. Over the name plate, see over the name plate, of course each and every device there has to be some name plate over it. There is a name plate. Okay, there has to be name plate. So there is a company name, then the wattage, how much power of that motor, then all the parameters like how much voltage it is made up of, how much current it can take, so each and everything. So there has to be some name plate. So over the name plate the parameter or the you can say the values has to be mentioned of the given motor. Okay, then there is a, see they have mentioned outer side which is cast iron, inner side there is a stator coil they have mentioned. Then this is what our squirrel cage rotor, see ball bearings. Okay, bearing steel. So this is how our assembly look like. Okay, then next see there is a stator. Now see this blue part which is outside part, which is made up of cast iron. Okay, cast iron, and inside there is silicon steel and which is laminated steel. So silicon steel stamping, steel lamination, right? So this is how single lamina of a steel we just make one assembly and putting inside the stator. So whole assembly you can say this is what your combination of your lamina, this is what your stator. Okay, it becomes a stator then. Okay, now inside this stator slot inside this stator slot we do the winding, which we just discussed about, that winding which is made up of enameled copper. Now when you are writing the answer, the construction of a 3-phase induction motor, you have to just write down first a stator winding, okay, stator. Then talking about the stator which is made up of silicon steel stamping which is laminated. Of course this is what the thing you have to mention in your answer, simple answer. Then there is a stator winding which is made up of copper, not only copper, enameled copper you have to mention. The stator winding which is 3-phase winding. Okay, now when we are doing winding 3-phase, it means we are making a 3-phase connection, and we have two types of connection, star connection or delta connection. So of course over the nameplate that is also mentioned star connected stator or delta connected stator. Okay, then this is how the stator or diagram look like. Okay, then next, rotor. Now there are two types of rotor involved in this motor. 3-phase induction motor, there are two types of rotor, but single phase it has only one type. But here there are two types. First, you already knows about this rotor, which is your squirrel cage rotor, which is actually look like a cage. We already learned about this. You know, there are the copper bars which is shorted by the end rings, and then this is look like a cage, right? So that's why we call it a squirrel cage. Here, see, this is what your squirrel cage, but this is not only the thing inside the rotor. There has to be lamination properly done, right? So this is how the rotor look like. Okay, so this is what your squirrel cage rotor exactly. See here, you can see the picture of a lamination, iron lamina inside the bars, right? So that the properly flux get divided and properly you can say uniform torque should be generated. That's why we do this thing. Okay, then this is how exactly the rotor look like. You can see there are the copper bars and end rings, copper end rings, and inside there is a, see, iron steel lamination, iron steel laminas, right? So this is how your squirrel cage look like. So this is what your squirrel cage rotor. So we so suppose your motor having squirrel cage rotor, that motor is known it as a squirrel cage motor as well. Okay, squirrel cage motor. Next is your slip ring motor, or you can say slip ring rotor. Now inside that rotor, see, there is again a rotor slots, you can say rotor laminations we done. Again that silicon steel stamping we use it over here to make the rotor lamination, and over the slot we do the winding like this. Now that winding again, which is 3-phase winding, which is again rotor winding, which is again made up of copper, not only copper, enameled copper. Enameled copper we use for the winding purpose, and the connection which is star connected as well as delta connected also. Now at the, you know, when we done with the winding terminal, it has to be connected somewhere, right? So it is actually connected to these copper rings here, these copper rings. So end terminal of these windings which is actually connected to these rings. Okay, now these rings we know it as a slip ring. Okay, that's why this rotor is known as a slip ring. So here you can get the idea. See here the winding which is star connected. See, star connected, the end terminal is shorted, right? Shorted, and other terminal are open where we can give the supply. But here I told you these terminal are putting, or these terminal are connected to this slip ring. Here these are the slip ring, Now you can see the terminal are connected to this slip ring, and other terminal you can connect to anywhere. It means you can add any extra circuit inside it. So they have added some extra resistance inside this rotor. So whenever you are using extra resistance, or whenever you are connecting extra resistance to the slip ring rotor, that time it will going to increase your starting torque. Always remember, when we are increasing the rotor resistance at the start, it will help you to increase the starting torque. So always remember, slip ring having a very higher starting torque. Getting it? Very higher starting torque. Okay, so wherever you need very high starting torque, there we use slip ring rotor. Generally, you know, if you know cranes, and there is a hoist which pulling a very heavy weight hoist. So at the hoist always we use slip ring motor, or you can say in a lifts also, bigger lifts, you know. So in the lift also we use slip ring motor. Okay, now see, this is what the slip ring rotor look like. Okay, there is a winding, or you can see the rings. Okay, now here there are two types of motors here. A, which is squirrel cage motor, 3-phase squirrel cage motor, and B, which is 3-phase slip ring motor. Okay, now these rings actually we connected externally with the help of carbon brushes, or sometimes copper brushes also, bronze brushes also, but generally we use carbon brushes to connect it with the external supply. Okay, sorry, 3-phase induction squirrel cage motor, and here 3-phase induction slip ring motor. Sorry, 3-phase induction slip ring motor. Getting? So this is what the construction.